So if we isolate the radical and we get square root of x minus 2 equals negative 3. Let's think about that. What do we know about the square root of x minus 2? It's always going to be what? Yeah, always going to be. Can you have a negative come out as a square root? No, unless there is a negative sign in the front. So this is always going to be positive. Negative 3 is always going to be what? Negative. So therefore, can they equal? Never. Yeah. So there's no solution here. So it's really important to know that when we square root, we can only square root a positive number, and it comes out as positive. That's really important to note here. So there's a key word we're going to use a lot, and that word is extraneous. Okay, so yeah, extraneous root. So sometimes when we solve, we're going to get two solutions. But one of them is going to be true, and one of them is going to be false. And the false one, that it comes out, we're working it out, and when we algebraically, we get it as an answer, but when we plug it into the original and check our work, it's not true. That's called an extraneous root, or extraneous solution. It's a solution you get algebraically that when you check it with the original, actually is not a solution. So we're going to write this down. A solution that emerges emerges from the process of solving the problem, but is not a valid solution. Come on. Okay, an example of that might be, well, we haven't really come across anything like that. Well, I guess kind of, this is somewhat of the same idea. When we did quadratics and we were graphing area versus width, and we would use the quadratic equation or something like that, and we get two answers. One was positive, one was negative. The negative answer was basically an extraneous answer. In that, can you have a negative area or width? No. So we'd only take the positive answer. It's kind of like the same idea. The extraneous roots come up with square roots because square roots are always going to be positive. And what happens is when we want to isolate the square, we're going to get rid of the square root. We're going to square both sides. And so when we square both sides, something emerges where we have two solutions emerge. Because if I square both sides, I get x minus 2 equals 9. Right? Like if I tried to solve this algebraically and I squared both sides. So if I square root of, oh my, that was wild. X minus 2 equals negative 3. So what happens is when I square both sides, that negative disappears. And same with the square root. And we get x minus 2 equals 9, or x equals 7. Okay, so here I get x equals 7, but when I plug it in to the original, and that's what we call verifying the solution. When I verify that is actually the solution, I go back to the original. Does the square root of 7 minus 2 plus 3 equals 0? Well, 7 minus 2, did I make a mistake? Yes. It would be 11. I can obviously subtract instead of adding. So let's go back here. That should be 11. Okay. So square root of 11 minus 2, what does that give you? What 9? Square root of 9 is 3. But 3 plus 3 equals 6. And 6 does not equal 0. And so therefore, what we would call this, x does not equal 11, this is what we call an extraneous root or extraneous solution. It's a solution that emerges when we solve algebraically, but when we check it with the original, it's actually false. And so you have to be very careful with that with this lesson. Because sometimes we're going to have extraneous solutions. Okay, usually occurs when squaring both sides. Oh, because it goes with that idea that because we're squaring both sides, if you square a negative, it's positive. You square positive, it's positive. And so when we do that, we get these two solutions, but really with the original, it doesn't work. Okay, so let's try these guys. When we're solving, we're going to do what I did up there. We always want to isolate the square root. You can't, like if I square both sides now, I'd have to FOIL, and it's not going to eliminate the radical. So what we want to do is get the radical by itself and then square both sides, because then it would actually eliminate it. So we move the constant over. Now, just by looking at this, I know that there's going to be probably a true solution, because positive equal positive, yeah, okay, that makes sense. We're not having a positive equal to a negative. So here, our next step if we were solving algebraically is we would square both sides, and we get, so just x plus 2, the square root and the square cancel each other out, equals what? 25, and then subtract 2, x equals 23. So with this stuff, we want to always check our answer, okay? And you can check your answer one of two ways. One, we could either make our restrictions and make sure it falls inside my restriction, or two, I just plug it in the original, okay? So if I plug it into the original, so verify would always be with the original. 23 plus 2 minus 5, does that equal 0? Yes, so that verifies. The other option, so that's one way to verify. The other way we can verify is check our restriction. Okay, so the restriction on the variable, and this is really important to know either way, is that x plus 2 has to be greater than or equal to 0. Remember how we talked about earlier how the radicand has to be positive? You can't take the square root of a negative. And so we know that x plus 2 has to be above 0. And so isolating x, we subtract 2, and we get x has to be greater than or equal to negative 2. So what did we get for x? 23. Is 23 greater than or equal to negative 2? Yes. That's the other way we can verify. Okay, is using our restriction, checking it, does it fit within my restriction? Okay, I feel like, yeah, let's just do this one really quickly. First step is always going to be isolate the radical. That's always step one. Isolate the radical. Is this large enough for you guys to read at the back? Yeah? Okay. So that's always step one. So move the 5 to the other side. Now with this one, right away, you might be able to see what? It can't work. There's no solution. Okay? There's no solution because I have a square root's always going to be a positive, and that's supposed to equal a negative. It's not possible. So we could say no solution. Now, if you solved it algebraically, then you would find that there has an extraneous root. So say I didn't realize that. Yeah?
So should we do it both ways when we're given this?
When you check?
No, when we're given this equation, should we, even if we realize that...
So if you got to this point, and you saw always, you could even just write always positive, always negative, no solution. That would be fine. Yeah, if you realize there. Otherwise, if you don't realize, which is more common to happen, is you go and solve negative 2, x equals 23, and then you verify. Okay, you can verify one of two ways. Now, the verification with restrictions doesn't always work. This method, because here we know, does this fit within, well, 23, we know x plus 2 has to be greater than 0. So x, again, has to be greater than negative 2. Is that true? Yeah, it fits in with my restriction, but it's still extraneous. So this, it's good to know your restrictions, but you still need to verify. You need to plug it back in and check. Okay, so the restrictions, yes, gives us what x should be, but the issue came in not because of what x should be, but because of this number. It's not possible for a positive plus a positive to equal 0. It's because that's constant on the outside. So you still want to check. And we're always going to show that check or verification. Okay, you're going to get a mark on your test for that. Okay, is that possible? No, we get 10 equals 0. No. So we call this, what's the name for this? Extraneous. The other thing I like to do on a test is in a numerical response, I would put this question on and I would say, solve algebraically, determine the extraneous root. Because you have to know what you're doing to figure out the extraneous root, and you can't find it on your graphing calculator. So there is ways to test that I know that you know how to solve a square root problem, okay? All right, let's move on. So step 1, isolate the radical, square both sides. Third, solve. And fourth, what's the last step you have to do? Verify. Okay, so make sure it's not extraneous. So let's turn the page. Yeah. Nope, not necessarily. So this last example, we got positive 23 and it was extraneous. So it's extraneous because this positive, we were trying to make this positive equal this negative. So your answer could come out as a positive. So just because it's negative doesn't mean it's not an answer or that it is an answer.
So negative is always negative 1?
No, not necessarily. For example, if I put in, my equation was root 10 minus x, okay? X could be, for example, negative 6, right? Because 10 minus negative 6 gives you 10 plus 6, or 16. And we could square root that. So depending on the equation. So, yeah, our restrictions are based on depending on what's inside. Okay? All right, so let's try another one. Step 1. Ooh, this one's fun. What's step 1? Isolate the radical. Add x to both sides. Okay, so we have root 3x plus 1. Oh, no, plus 3. Equals what? X plus 1. Okay, step 2. Square both sides. So step 2, after we isolate, we square both sides. Now here's where it gets really fun. The left side is beautifully easy. We square root a square, what happens? We just get, you just get itself, right? They cancel each other out. So the square root and the square cancel each other out. Super easy, life is good. Where students will then write equals x squared plus 1. Ooh, it breaks my heart. I got foiled by foil. Right? Yeah. This is where our knowledge of quadratics comes in. Hooray! You thought you were done with quadratics? They're back and they're haunting you. We've got a foil. So that step 3 of just solve is not always as simple as just solve, right? So we FOIL this. X times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1. And how do we solve quadratic equations? Everything on one side. It all moves over. So we need to move over the 3x and this 3. Oops, I don't want red anymore. 0 equals x squared. So we had 2 x's, right? Because x plus x is 2x. Minus 3x is how, what? minus 1x, right? We have 2x minus 3x becomes, and then 1 minus 3, negative 2. Okay, how do we, now that everything's on one side, what do? We always try to do. Factor. 1, 1. 2, 1. Who's negative? The 2. We want to add to negative 1. So our solution is 0 is equal to x minus 2 times x plus 1. And then what? X equals what? Remember, this is the part everyone forgot to solve. 2 and negative 1. Okay, once we're done that, we're now done step 3. The last step we always have to show, and that's the verification. You're getting a full mark for your verifying. And we have to do it for both. And you always have to use your original equation. So root 3 times 2 plus 3 minus 2 has to equal 1. So plugging it into the original. So this is our verification for x equals 2 right now. Okay, 3 times 2. 6 plus 3. Root 9 is? 3 minus 2? 1. Works. 1 equals 1. So that means it's true. Okay, let's try another one. 3 times, now let's do x equals negative 1. Minus negative 1 has to equal 1. Okay? What's 3 times negative 1? Negative 3 plus 3? 0. So we get root 0, 0. And then negative minus a negative 1 is the same thing as plus 1. Is 0 plus 1 equal to 1? Are there any extraneous solutions? No. So there's 2 answers. So there can be 2 solutions. Especially these ones with a variable of x on the inside and the outside. So I'd like you to try number 4. Hooray! Okay. Now once you get your solutions, guys, make sure you show your verification. So once, just check. I won't show the verify just yet. And then I type. Okay, so the y1, you're going to put as the left side of your equation. Make sure that if you have brackets, you close the brackets for the square root. Or if you have my version, you push the right arrow to get out. Okay, so that would be y1, y2 is the other side of the equation. And we want when these 2 lines are equal. So guess what we're going to find? Intersections. So now we're going to find the intersection. I shouldn't even show you this. Okay, you might have to zoom out. I'm not sure. Let's try it. Second trace, number 5. So we're typing in second trace 5 and enter 3 times. 1, 2, 3. And there it is. Now, do we want the x or the y? No. Just the x. Always, well, because we're looking for what x is. We bet y, notice we had y equals 8 as one of the equations. And we want when this is equal to 8. So we're looking for what x is. X is 9. And so 9 is a solution. You can check if you want. Does root 9 plus 16 equal 8? Well, we get 3 plus root 5, which is 8.
You can do that for everyone.
If it's a multiple choice question, you can. If it's a numeric, I'm asking for extraneous, no, or written response, no. You have to be able to solve algebraically if it's written response, because that's what I'm going to ask of you. I'm telling you now. Okay, you can also check your work with it. Do I want to do this question? Does it look hard? Okay, then we should do it. What is the speed in meters per second? Yeah. Sorry. Okay, here's a nice thing about math, right? In mathematics, we don't expect you to put the units in your substitution, just at the very end. We give you the equation, we spell it out for you. It's not like physics, right? We tell you that we have a 4-kilogram football. What does that represent? Which variable? 0.4 kilogram football. That's mass, okay? We also tell you that 28 joules of kinetic energy, that's EK. And guess what we're solving for? V. What is the speed? We're looking for V. Okay? Quite simple, really. So we sub in what we know. Okay. Where would you start with this? Okay. You can multiply both sides by 2 if you want. Want to do that? Is that what you want? Okay. Times by 2, times by 2. That gets rid of the 1/2. 28.8 times 2. Oops. 57.6 equals 0.4 v squared. What's next? Divide by 0.4. See, in physics, they make you rearrange the equation first. In math, we can sub it in and then rearrange. So that's nice. Math is way better. Right? Okay, 144 equals v squared. Then what? Square root. Okay, when you square root both sides, guys, you get 2 answers. One's a positive, one's a negative. Root 144 equals plus or minus 12. But can you have a negative velocity? Well, actually, you can. So we're going to take the positive. So the speed, because it could either be up or down, right? It depends on its direction. But so what's the speed? It's asking for the speed, not the velocity. Is 12 meters per second. Okay, so really not that bad. I'm going to skip the 3D question, I think. Did you guys skip it this morning? You did it? That's all? Okay, you want to do me one more favor? Skip this question and that, and go to the very last page. Okay? Okay, something like this, really quickly. If I were to solve this, what's my first step, algebraically? Okay, bring the 4 over. So algebraically, we're almost done, guys. We're going to go through this super quick, I promise. So you said first step is bring the 4 over. Then what would you have to do?
What about the question?
What question? We're skipping it.
So why?
We can do it later if you want. Then you would divide by -2. What happens if you have 2 negatives? 2 positives. Okay? So root x minus 3 equals 7 over 2. What would be your next step? Square both sides. So that gives me x minus 3 equals, what's 7 squared? 49. What's 2 squared? 4. So 49 over 4. Then our last step is to do what? Add 3. So when you add 3, goes it's 3 over 1. We need a common denominator. What would that be? 4. So it becomes what? 12 over 4. Right? And when we add fractions, we add the numerators, keep the denominator the same. 49 plus 12. 61. So there's our solution. Okay? If I wanted to solve this graphically, what would we do? Okay, y1, what would y1 be? Clear. Clear. -2 square root x minus 3. I'm going to show you something that's really cool, okay? Plus 4. So left side of your equation is y1, right side is y2. Left side, right side. Graph it. You might have to, do we have to move? Yeah. You have to be able to see your intersection point. We can't see it, so I need to go this way. I need to make x larger. So go to our windows, and let's just make the x max 20. Sure. Let's try that. Perfect. We can see the intersection. Okay, now what? Second trace. 5. Enter, enter, enter. Now, gives me 15.25. Here's a really cool thing. Whenever you find your intersection, automatically this xy and this x value and this y value is stored in your calculator as those variables. So if you got a really ugly decimal as your x, you can just see this is my x. It's stored. So I could go x, math, enter, enter. 61 over 4. Awesome. Okay, so automatically it's stored in your calculator as the x. And the y we don't need, but it is stored alpha 1, okay, as -3. So if you, would have been really helpful if you did that in grade 10, right? Why don't they help these? Because I wasn't your teacher. That's why.
So you have to go yell at Sweeney.
Totally. Okay, I will. He might not even know that. I don't know. Maybe he does. Okay, so that's what I wanted to show you. That is the end of the lesson. Yeah. Stop.